Okay, welcome. So this video will go over finding the derivative of the square root of x using first principles. So again, as usual, we'll always start out with the limit definition of the derivative. So we have f prime of x. So again, it's equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So again, copying the limit notation down. So now we're just plugging in f of x is equal to the square root of x into this equation effectively. So f of x plus h just means we're plugging x plus h into here. So we have the square root of x plus h minus just the square root of x. This is all being divided by h. Okay, and this is a step where there's going to be an algebraic manipulation strategy. That's kind of like the core step that we're going through here. So we're going to multiply here by, again, the conjugate, meaning if we have like a plus b, the conjugate is a minus b. So in this case, we have the conjugate of root of x plus h minus root x is root of x plus h plus root of x. So we have root x plus h plus root x. And this is being divided by same thing. Again, we're able to do this because, again, effectively, we're just multiplying by 1. So in the next step, we're just going to multiply across. In the top, recognize that we do have something of the form of a minus b times a plus b, which hopefully you do recognize as the difference of squares. So we know that a minus b brackets times a plus b bracket will give you a squared minus b squared. So in this case, this is your a, this is your b. So x plus h squared is just x plus h. Root x squared is just x. So what you end up having is x plus h minus x. Again, do not forget to divide by all of this here. So it's h times root of x plus h plus root x. In this step, we can then make a simplification. So let me just write the limit notation down again. So here the x's will cancel out. And then what you're left with is h divided by all of this. Well, hopefully from here, you can also see that the h's will also cancel out, meaning in the numerator, you're just left with a 1. So you then have 1 over root x plus h plus root x. And then from here, we can now drop the limit notation because we are doing a direct substitution to finish things off. So we then have 1 over root x plus 0 plus root x. And then from there, we just have root x plus root x, which is 2 root x. You have 1 of something plus another of that same thing. You have 2 of that thing. So this is divided by 2 root x, and we're done. And again, you can always quickly check to verify that this is correct. We can always, again, write root x as x to the power of 1/2. So you have f of x is equal to x to the power of 1/2. And then if we just use the typical power rule, so derivative rules, in order to try to find the derivative, you'll see that it does indeed check out. So you have f prime of x. So again, you move down the power, subtract by 1. So negative 1/2. And then if we express this as just a fraction, as a rational number, we then just get 1 over 2, and then root x. Again, you'll notice that these two do indeed check out. Perfect. Thank you for watching.